This is Tech Math 2, and we're in chapter 1. And the plan is to do section 1.1, 1.2, and 1.3 today. Okay, in section 1.1 we find that we have whole numbers and whole numbers are 1, 2, 3. Whole numbers are not negative, whole numbers are not 0. We have integers, if I spelled integers right, which I probably didn't. Those are, did I spell it wrong?
Yeah.
Okay, excellent. So plus or minus 1, plus or minus 2, all the negative numbers, and 0 is also an integer. And all the whole numbers are also integers. And then we have rational numbers. And rational numbers would be a half, a third. Those would be rational numbers. Plus or minuses are okay. All the integers are rational numbers. All the whole numbers are rational numbers. Then we have irrational numbers. And irrational numbers would be like the square root of 3 and 4, the square root of 7, things like that, 1 over the square root of 2. So those are rational. They stand by themselves. Irrational. So a whole number, an integer, and a rational number would not be irrational. And then we have transcendental numbers. And I misspelled that too. Transcendental numbers. So pi is a transcendental number. E, the base of natural logarithms, are transcendental numbers, and all multiples of those are also transcendental numbers. So we have an infinite amount of whole numbers, an infinite amount of integers, an infinite amount of rationals, infinite amount of irrationals, infinite amount of transcendentals, and all those guys lumped together to form what we call real numbers, which is what section 1-1 is about. So real numbers. And real numbers are things that we've had to deal with, the only things we had to deal with prior to 1820. After 1820 we got imaginary numbers, but before then there were no imaginary numbers and life was much more easier for us. And what can we do with these things? Well, we can add, subtract, multiply, divide, things like that. Alright, so now the issue is I got 4 minus 1, and I've got 4 plus minus 1. And in the first case I have 3, in the second case I have 3. Alright, seems reasonable. Alright, so now I've got 4 minus 1 squared, and I've got 4 plus minus 1 squared. Okay, in the first case I have a 3. In the second case, I have a 5. So for the minus sign in this case, meaning subtract, it doesn't mean 1's negative. The minus sign in this case means the 1 is a negative number. When I square a negative number, I get a positive number. Okay? So I've got something like minus 4 squared plus 13 equals. And I got minus 4 squared plus 13 equals. In the second case I have, what do I got? 29. 29. In this case here I got minus 3. Because that squaring is squaring the 4, it's not squaring the minus sign, unless I put parentheses around it and clearly indicate that that's what I want. So if I have minus 1 over 2, that's the same as minus 1 over 2, which is the same as 1 over minus 2. There's no difference in any of those. All those guys mean the same. I can't differentiate them as being different. It's all minus 0.5. Okay, I'm looking at the homework. At any moment you can say, you're going too fast, slow down. Well, not in chapter 1. Okay. Yes, you could. Number 8. Oh, I got absolute values. We didn't cover absolute values. So if I have the absolute value of A is equal to what? Well, it's going to equal to A if A is greater than 0. It's going to equal minus A if A is less than 0. All right, so if I have minus 2 absolute value, if I could make an absolute value sign, then minus 2 is less than 0, so this is going to be minus a minus 2. Oh, that makes it a positive 2. All right, so if I look at y is equal to x, and I make a graph of that, and I say, well, y is equal to x, boom, there we go. And minus 4 here, minus 4 there. All right, y is equal to x. Or if I look at y is equal to the absolute value of x, then I end up having something that looks like that. So when x is negative, my answer becomes positive. All right, back to what we were doing before, number 8. I want the absolute value of 1 minus a minus 6. All right, well, minus a minus 6 would be 1 plus 6, which would be 7. 7 is positive. The absolute value of 7 would be 7. All right, yes?
I was showing the work for that. You can write all that out, or
You mean that whole huge line?
yeah, I didn't write it out. I just put 7.
You just want to put 7 down? All right, now, so here's the issue. You did it in your head. Put down 7. You had to. You need some help to get the right answer. Put down all the help you need to get the right answer. Okay? So I'm not interested in you going to the back of the book and writing down the answers and passing that in as homework. Now, I am interested in you working the problem. So if working the problem means I do it on a calculator and I trust my calculator to give me the right answer and I put it on, it's perfectly okay. When we get to chapter 30, there's going to be 3 pages of work for every problem. You can't do them in your head. Right? No problem. Can't do them in your head anymore. Big deal. Unless you had a TI-89 calculator that told you what the right answer was, then you could be in the same situation. Number 39. Okay, so does that answer that question? All right. Number 39. All right, so I've got plus 1/12. What's the plus sign there for? Just to distract the student. Minus 1 2/3. Now, our 8th grade instructor would have told us that our common denominator is a 12, so we're going to go get it, right? So we get 1 over 12. We change this to an improper fraction. 3 times 1 is 3, plus 2 is 5 over 3. We multiply top and bottom by 4 over 4, and we get 1 over 12 minus 20 over 12, which is going to be minus 19 over 12. Now, this is a tech math class. That's not what I want you to do. What I want you to do is take out your calculator. So I go and I take out my calculator and I put in 1 divided by 12 minus 1. Then I have second function, no, wrong guy. Delete that guy, move back. Second function, all right, there we go, I got it. 1 minus second function, the 7 key, 2. 2, the second function, the 7 key, again, 3, enter. Syntax error, when you know it. Stupid calculator. Anyway, so what is it doing? All right, so I'm gonna delete the whole thing. Minus minus parentheses. 1 plus 2 divided by 3. Close parentheses, boom. 1 divided by 12 minus parentheses 1 plus 2 thirds, close parentheses, 1. And it still gave me the decimal. So I had to go back and change the decimal to a fraction. But I still got minus 17 and 12. Now, it's a tech math class. You give me minus 1.58, perfectly okay. You give me minus 19 or 12, perfectly okay. I wouldn't you give me minus 1.583 with a repeating sign over it, that'd be perfectly okay. Okay, because when we cut with a chainsaw, how close to a ½ inch do we get? Yeah, well, not to the nearest hundredth. Okay, so that's a different issue. Okay, what are we doing? 66. If for some reason these things are foreign to you, you should do every single problem in this problem set to correct that problem, whatever it might be. All right, so I got minus 3, I got 5, I got minus 8, I got 2, I got minus 1. So the first thing I do, I got 1, 2, 3 negative signs. So my answer is going to be negative. All right, so 5 times 8 is 40, 40 times 2 is 80, 80 times 3 is 240. So I'd expect the answer to be minus 240. Now, there's a difference in your calculator between the subtract key and the negative key. Okay, so this minus 3, we have to put in with the negative key. Minus 3 times 5 times minus 8 is the same way, times 2 times minus 1 equals. And because I put it in with the minus, not the subtract key, I get minus 240. If I use the subtract key and I said subtract, well, subtract 3 times 5 times subtract 8 times 2 times subtract 1, I'm going to get a syntax error because that's not what I want it to do. I want the calculator not to multiply subtract. There's no operation. There's no multiply subtract operation. There's add subtract multiply divide and so on. So but if I use the negative key instead of the subtract button, then I'm telling the calculator this is a negative number, which is what I want to tell it. All right, problem 72. During March, Mary's small business income was $18,750. She is going broke, and her expenses are $20.55. Find her profit. Well, I put it that way because I'm going to subtract. I'm going to get a positive number, but I know her profit's going to be negative, right? 5 from 5 is 0. 7 from 5 is 8. 8 from 9 is 1. So she's got a minus $180 for her profit. So I put it in my calculator and I say 20, clear. 1875 minus 2055. Oh, minus $180. She is going broke. All right. So we're done with section 1. Now we're going to go to section 2. All right. So we're going to do things with zeros. Now, the idea of a zero, the idea of nothing, would have been foreign to everybody 2,000 years ago. So you walk into a town, how many houses are there in the town 2,000 years ago? So I walk into town, and there's this house here, and it's Doug's, and there's this house here, and it's Cassandra's, and there's a house here, and it's Tony. How many houses are there? No,
Zero?
no. 2,000 years ago, there's Doug's house, there's Cassandra's house, there's Tony's house. There's not three houses. They would not have thought about it as there's three of them because they're all different. It's my house. It's your house. They would not have, the mind, the thoughts that's in the mind would not have been that way. Yes.
So would the answer be one then?
No, it would be, there's Doug's house, there's Cassandra's house, there's Tony's house.
Okay.
It never would have crossed their mind that there were three of them.
Oh, okay, I get it, yeah.
Yeah, it never would have crossed their mind. So we're in the Old Testament, some battle on the battlefield that's 2,000 years before Christ is born, and there's 100,000 men there. How many men were there? The concept of 100,000 didn't exist. Okay, there were a lot of guys there. Okay, yeah. Okay, but they had no way to count to 100,000.
That number didn't exist.
That number didn't exist. That number didn't exist until 650 A.D. So how the original text was written and how we managed to translate it when we did the King James Version of the Bible is interesting, and now we're stuck with it, and we think that that's the way it is. But so and even in Revelation, where it's saying 144,000 are going to be saved, 12,000 from each tribe of Israel. Well, those numbers didn't exist either. That's a translation that we did using our modern mathematics. What does it really mean? Anyway, so but now we have a zero. In 650 A.D., the Moors of northern Africa gave us a zero when they gave us the decimal system. Most brilliant thing ever to happen in the history of, well, not totally brilliant, but yeah, totally brilliant. Totally amazing. So in your digital circuit class, you had an OR, so A or nothing was A, right? Well, math is almost the same way. So I add nothing to A and I get A back. I subtract nothing from A and I get A back. And I multiply something times A and I get nothing back. And if I multiply two things and I get zero, then there's only one conclusion that I can have. And the conclusion is that A is zero or B is zero. They could both be zero. That'd be perfectly okay. But one of them has to be zero. If I multiply two things together and I get zero, one of them has to be zero. I have no other choice. If I go and I take zero and I divide it by something, I get zero. But I'm not allowed to have B to be zero yet. Not until chapter 23. What happens in chapter 23? Oh, when we get there, if I have A over 0, we're not allowed to do that, and the text math book declares this as meaningless. Other people would say something other than that, because A cannot be 0. And if I have 0 divided by 0, then that's not determined, indeterminate. Indeterminate. So in this case, we're never allowed to divide by 0, even in chapter 23. But we can have something in the form 0 over 0 that's going to come up with an answer. So let's look at x over sine x. Why not? And we look at the limit of this as x goes to 0. And we say, well, that looks like, that's in the form 0 over 0. The sine of 0 is 0. I can't have an answer, right? In chapter 23, it tells us that we can, L'Hopital's rule tells us that we can take the derivative of top and bottom and have the same answer. So the limit as x goes to 0 of 1 over cosine x is 1. Therefore, the limit of x over sine x is also 1. You say, Cordell, you're foolish. Okay, well, so we'll get this Excel spreadsheet here, and we'll look at it. We'll get closer to 0 and see what happens. So we'll view, zoom, 200. All right, so we got this guy. So we're going to go A1 divided by the sine of A1. All right, can't do it, you're dividing by 0. Okay, so we'll put a 1 there. All right, that looks good. And then we'll go and do a copy, and we'll just go that far, paste. All right, so we're going to look at 0.1, and then we're going to look at 0.01, and then we're going to look at 0.001, and then we're going to look at 0.0001, and then we're going to look at, see if we can get more numbers there. That's better. 0.00001. Still don't have enough. All right, so we got the 1 already. We're going to have more significant digits to get off the 1. But as I'm approaching 0, I'm approaching 1. So that's why it's saying in chapter 1 that 0 over 0 is indeterminate. So it might have an answer, it might not. I just don't know yet because I don't have enough math. But A over 0 is never allowed. So I'm never allowed to do that. Okay, good enough? All right, so now we have the issue of order of operations. So whatever happens inside parentheses has to happen first. If I have powers, that have to happen next. If I have multiplication or division, that happens next, and it doesn't matter what order. I can multiply first, divide first, doesn't matter how I write it. And then I do adding and subtracting last. That would be my last order of operation that I would do. And my calculator will follow those rules religiously forever and ever. So I don't necessarily have to remember them. But when we had the problem of -1 squared, that was an order of operation. So the power guy happens first. I square the -1 before I do the negative guy. Whereas if I have -1 in parentheses squared, I do the parentheses guy first. I've got a -1 that I'm squaring. See the difference? Subtle. Is it subtle? It's no different than you were taught your entire life, right? Okay, I'll accept that. All right, problem number 3 is going to be next. And let's see, anybody know what 6 times 0 is?
0.
Are you sure? Let's see, 6 times 0. Oh yeah, that's what my calculator says. Cool. Yep, you're right, it was 0. That's really great. 18. Is it really that simple?
Yeah, I know, I tried
Yeah,
this
it is.
one yesterday, and I got it said a 0 error or something on the calculator.
So 18.
I couldn't figure
Find
that one out.
the value of x that makes it meaningless. Okay, so 3 over x, x plus 1, x minus 1. Okay, the definition of meaningless is I have something divided by 0, right? That being the case, the answer would be x would be equal to 0. When x is 0, this is meaningless. X could be -1. When I have -1, I'm dividing by 0. It becomes meaningless. X could be 1. It'd be meaningless. So it goes back to the definition of meaningless. So instead of asking you the question x plus 1, x minus 1 is equal to 0, find all the possibilities of x, which would be a reasonable thing to ask, right? and you say, well, x is going to be 0 minus 1 plus 1, it says, instead of asking that question, it asks the question, what are the values of x that make the equation meaningless? Is this an English class? They shouldn't have done that. I mean, that should not be in chapter 1. No one cares about meaningless things. You can't divide by 0, period, the end. Anyway, does that answer that question? You see what you're doing wrong? Okay, so how did you formulate an answer?
I just typed in the calculator is 3 over, what it is there, and then I got like a 0 data error or something.
Yeah.
I want to know what that is.
So what you were doing in your calculator is you were saying, I got something, and it's equal to something, and I'm finding out what the x's are, right?
Yeah.
Well, but that's not what you have. You have the something, but you don't have it equal to anything.
Okay.
And that's the issue. So that's why your calculator wouldn't do what you wanted it to do, because you don't have something that says I'm equal to something. I have something that you have to do differently. So if you go on your calculator and if I go second function numeric solve, and I put in from x times x plus 1 parentheses times x times parentheses x minus 1 close parentheses equals 0, and I hit the enter button, and it's going to tell me when I go to solve for x, it's going to tell me that minus 1 is an answer. And when I'm solving again, and it's just going to give me the minus 1 answer, even though I know there's a plus 1 answer and a 0 answer, it's only giving me 1. So I can do that. Oh, yeah, I can do it again and say, I'm going to start with x at 1.5. And I solve for that, and I get x is 1. And then I'm going to solve again, and I'm going to start with x at 0.25. And I'm going to find that x is 0. So it will tell me that 0, 1, minus 1, but that's a convoluted way to force your calculator to get an answer. When I can look at it and write down the answer, I know it has to be 0, 1, or minus 1. But I can force my calculator to do it if I, with that type of guy, which I am, so I did. Find the values that make it indeterminate. All right, so this is more interesting, 24. 3x minus 6, 1 minus x, x minus 1, 2x minus 6. And we want to find the values of x that make this guy 0 over 0. So in words, that's what it's asking us to do. Okay, so if the top guy were 0, if 3x minus 6 times 1 minus x were 0, then that would imply that x can be 1. When it's 1, then this guy's 0, and x can be 2. And then I look at the bottom guy, and I see x minus 1 times 2x minus 6 is 0. And I see that x can be equal to 1. X can be equal to 1. And x can be 3. So the only case where we have 0 over 0 would be x is equal to 1. So the answer is x is equal to 1 is the case that would be indeterminate. Okay? Going to 48. 48 divided by 4 divided by 3 times 6 minus 3 divided by 4 plus 2, 6 minus 2. Okay, so I wrote down the problem right. Well, the division and multiplication doesn't matter what order we go. So 4 goes into there, 12, 3 goes into 12 4 times. 4 times 6 is 24, minus 3 is 21. So I got 21 on top. On the bottom I have to do inside parentheses first. So I've got a 4 times 2 is 8, plus 4 is 12. So I should get 21 over 12. So I'll just put it in my calculator. And so I got 48 divided by 4 divided by 3 times 6 minus 3. I'm going to hit the enter button and I get a 21 on top, and I'm going to divide by, put a parentheses down, 4 plus 2 times parentheses 6 minus 2, close parentheses again, and I get a 1.75. Second function, change it to a fraction, I get 7 over 4. So now the issue is this 7 over 4?
Yeah.
Yeah, it is.
Oh, I got it.
Yeah, 7 over 4.
But I simplified it too and did 1 3/4.
Yeah, 1 and 3/4 would be perfectly okay. So 7 over 4 is fine, 0.14 is 4 is fine, and 1 3/4 is fine too. If this were not a math class, was not a tech math class, then the instructor would have to tell you what form they wanted the answer in.
Okay.
I want a complex, I want a improper fraction, I want a proper fraction, I want a decimal number. In our cases, a tech math class, all three would be perfectly okay. We don't really care which one you put down.
Oh, cool. All right.
Okay, so this is 48. Now we're in section 1-3, and we're looking at scientific notation. So scientific notation is xxx times 10 raised to some power, x. So if I have 3, 4, 5, 9, 7, then my scientific notation will be 3.597 times 10 to the 1, 2, 3, 4, fourth power. If I had 0.0000123, then my scientific notation 1.23 times 10 to the, move the decimal point, 1, 2, 3, 4, 5 times minus 5. That's what I would do. Now, my calculator will give me the same answer. So if I go to mode, and I tell it I want scientific notation, so now my calculator is in scientific notation, and I put in 0.000123, then it gives me 1.23 times 10 to the minus 4. And if I put in 34597, it gives me 3.4597 times 10 to the 4th. So my calculator, if it's in scientific notation, will give me the answer in scientific notation. Isn't that lovely? Okay, I guess that's all there is. Okay. If I have 10 to the 10th and I divide by 10 to the 9th, then that's going to be 10 to the 10 minus 9, which is going to be 10. So if I have 10 to the m divided by 10 to the n, I'm going to have 10 to the m minus n, and that's just a different way to go and add things together or whatever. If I have 10 to the m times, that's an m, 10 to the n, then that's going to be 10 to the m plus n. So exponents add when the bases are the same. So if I have 10 to the m times 5 to the n, then there's nothing I can do about that except multiply it out and add it together. or whatever. I can't, those bases aren't the same. I can't add the m and an n. Can't do that. Okay, we're looking at problem number 9. We have 3 minutes to do the problem set. No, we don't. We have more than that because your next class is in this room. You don't have to go anywhere, right? Number 9. I'm sure we can get it done in time. 1 over 10 to the minus 4 is 10 to the 4th. Okay, now, your 8th grade algebra teacher told you don't have negative exponents in the denominator, right? Okay, so so 10 to the 4th would be the proper answer. That's the same for our class. We wouldn't leave a negative exponent in the denominator. Number 18. Okay, 10 to the 5th, 10 to the minus 2, 10 to the minus 6, 10 to the 3rd, 10 to the minus 4, all raised to the minus 3. Alright, so 5 minus 2, that's 10 cubed, minus 3 minus 10 plus 10 to the minus 7, raised to the minus 3. Minus 7 goes on top, 10 to the 10th, raised to the minus 3, 10 to the minus 30. We wouldn't leave a negative exponent there either, so we would call it 1 divided by 10 to the 30th. In this particular case, there's nothing wrong with that answer because this is a tech math class, and there's nothing wrong with that one because it's a tech math class. The 9th grade algebra teacher told you don't leave them in the denominator. She didn't say about leaving them in the numerator. 30. And again, I could do that at my calculator if I really wanted to. I got 0.000. Are there 3 of them? 1, 2, 3. 102. And I want to write in scientific notation 1.02 times 10 to the minus 1, 2, 3, 4. And number 54. Does it really go that high? Oh, you got to be kidding me. Anybody got an answer to 54? Okay, well, we have 3.86, 10 to the 5th. We've got 1, 5. Now, back when I was your age, well, some of your ages, we didn't have calculators. We had slide rules, and we'd have to do this problem with a slide rule, which made it very interesting. I did it again. How come I did it twice? 1.1991, 10 to the 8th, divided by blah, 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 whatever it is. So what I do on the top is I'd have 3.65, 3 point whatever it is, 5.15, 1.91, and then I'd say that's 10 to the minus 9, minus 1, 4th power. And then I'd do the same thing on the bottom, 2.34, 1.35, 9.05, and then I'd say times, there's a 10, there's a 6, there's a 12. All right, so whatever my answer is going to be, I'm going to have times 10 to the minus 8th. All right, so then I put the numbers in my calculator. 3.86 times 5.15 times 1.91 divided by 2.34 divided by 1.25 divided by 9.05, and it looks like I got 1.33. My calculator says 1.328, but I only have 3 significant digits in all my numbers, so I'd only keep 3 of them. Okay, good enough? All right. Control off F12. This ends section 3.